Okay, we're back, 5.4, Fundamental Theorem of Calculus, looking at a function that is sort of sweeping out area. And I've given you a picture of f of t. We've found all of these values. I even put them in a chart. I decided to go ahead and put them in a chart over here. I'll need that for d. So is 0, 0, 1 is a half, and so on. Down here, if you want to stop and put that like that. We don't need it right this second because we're looking for maximum. So when this is sweeping out area, we've got a half and then 0 and then negative a half and then 0 again. And it isn't until this point that it starts sweeping out positive values, completely positive. So it's 0 from here to here, and then it's positive. The function values positive, 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 all the way to here. When we look at that was 5.5, that is the most, that's the maximum. So our maximum is at x equals 7, and the maximum is 5.5-ish. The minimum, well, let's see, if it's positive here, that's going to be positive 1/2, and then it's 0, and then it's negative. So from here to here, or from 0 to here, it's negative 1/2, and that was the smallest value we came up with up here. So we would say that that occurred at, where'd that occur? At 3. At 3. 1, 2, 3. Yes, at this point right here. So at x equals 3, we have a minimum of negative 0.5. Kind of an interesting way to think, huh? Trying to create a function that represents area. Now D, we're supposed to sketch a rough graph of G. So what I did was, that's why I listed all these. So I can actually just plot. And this is x-axis and y-axis. So 0, 0, 1 is about 0.5, 2 is 0, 3 is negative 0.5, 4 is 0, 5 is 1.5, 6 is up here at 4, and then 7 was up at 5.5. So a rough sketch would be something like this. All right, pretty cool, huh? There's g of x. And I will be back for number 2.